Now you have a few examples down here. The first example has a number from 1 to 10, and you have all this the given other parameter days equals 5. And you'll see this example shows that the ship capacity 15 is the minimum to ship all the packages in 5 days. And you'll see that the example is basically indicating you cannot uh, break the weights. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are the weights given, right? You cannot just pick and choose. Let's say I take 1 and 6 and 9 in one single shipment and 3 and 4. You cannot just go in a random order. You have to follow the order. And if you do that, you have to just select a weight. And let's say, for example, we know somehow the capacity is 15. In that case, if you take 1, then 2, the total load is 3. And if you just add this one, the total load is now 6. And then if you add this one, 4, the total load is now 10. And at fifth, if you just take this one, as well, then the total weight will be 15. And at this point, this is first shipment, right? This is one shipment. And then, and each shipment is sent in one day. So this is one ship, and this is one day. So this is what we're looking for, the count of the days. Uh, and we need to know the capacity. So now at this point, there's one shipment is sent in one day. Now the next shipment is going to have start from here, 6. So now the total load is 6. And here at 7, it is going to have a total load of 13. And by the time it reaches 8, and this is shipment 8, the total load would be 21. But we know the capacity is now 15, so you cannot actually do that. Instead, you have to just ship this 2, and this 8 will be the total load for this one. So this is first day, and then this 6 and 7 will be in day 2. And then from 8 and 9, the total load will be 17. That is not possible either. So in that case, you have to just ship this load with value 8 in one shipment. And then the next shipment will actually have 9. And if we need to just find the next day, this is going to be 19. That's not possible either. So you have to ship this 9 load in one another day, which is the day 4, and then the 10th ship load another day is day 5. And in this case, you can see you basically need 5 days to ship all these values. So let's use another color. So these are going to be the shipment 1, 1 to 5, then from 6 to 7 another day, and 7 and 8 in another day, and 9 and 10 and separate days. So total 5. And if you see, if you just increase the capacity, in that case, if you had a capacity of 16, in that case, you will be able to just ship in less days because you could uh, actually fit in more weights in one shipment. So it will take less than 5 days, but you don't need to just do that. You need to find the capacity, which is just enough to ship all these packages within 5 days. Now, if you had a load which is less than 15, it would definitely mean you will not be able to ship all of them in 5 days. So that is not going to work. So for this problem, you can think of different ways to solve, but if you notice that you are trying to find a value and you're trying to just minimize that over a search range, and it can be solved using a binary search, and that is going to be a very efficient solution. And for this particular problem, there has to be a strategy how you are going to solve this. So if we take all these numbers in weights, weights array. So, and let's call its length as n. Now, if you just take all these values in that order, then you need to search for the capacity which lets you ship within D days, right? So this is a given days. It can be 5 or something else is a parameter. And the weights array is also another parameter. Now we are trying to search for the capacity. Capacity is something we are looking for, and we're trying to just find the minimum capacity that lets you satisfy uh, this condition that you can ship within D days. And for this search for the capacity, you can observe the range. So if you look at on the left side, the number of days is between 1 and n. And this is again less than 5 to the power 10 to the power 4. So this is the range. So now if you know this range of n, so that means you it, it is possible to ship everything at least in one shipment and up to as many shipments as the number of weights. So that means if you had all of the ship weights shipped in one cargo, then you could actually just reach this number. So if you had everything bundled up, so you will be able to just ship in one day. On the other hand, if you had the maximum value of this weight array, in that case the maximum weight, and that if that is the capacity of the ship, in that case that is one uh, load you can ship in one day, and all the other smaller shipments can be packed up and shipped on a different shipments. And that would mean you will have a value which is less than n or as equal. So for example, take this example on the left, 1, 2, 3, 1, 1. So in that case, you had the maximum value is 3. If you had a capacity of 3, this is going to be one shipment, right? So it's a one day. And if you had 2 and 1 together, this will be another day. And the last one and the last one can be together, so that's another day. So if you took the max value, in that case, you'll definitely be able to just ship it within n days. But we don't know if the given days is n or less. But anyhow, this is a uh, uh, good value that gives you an upper bound. It has to be within the days, right? So this is going to be an upper bound for the search range. So now if you think about this is our capacity that we are searching for, it has to be able to ship within one day. So if you translate this condition, n days is less than n and greater than or equal to 1. So 1 happens when we have the summation. Sorry, let's fix that. Uh, Summation of all the weight values. So that gives you all the capacity where everything, all the weights can be shipped in one day. So that satisfies this condition. And on the other hand, if you take uh, the uh, if you take the max value of the weights, in that case, you'll be able to ship somewhere between 1 and n, right? So that is a good range. But in fact, summation is definitely uh, greater than this. So in practice, the relationship would be like this. Yep. So this is the left side of our binary search, and this is the right side of the binary search. So summation of weights is the max value of the capacity, and the max value of the weights is going to be the smallest number of the capacity. So and we will just do a binary search every time, and we'll assume a capacity and see if we can actually ship all the weights within D days if that is the capacity using binary search. Now, if you notice, we will need to first go through all these numbers in the weights array to find the max and the summation of weight, right? So that is going to be a linear runtime. And then after that, for this search range of the values, we will actually uh, have a binary search, and we know the binary search is have uh, this complexity. But for each binary search, we also need to validate if we can ship all of the shipments within n days or d days. So we will need to, for each of the binary search, we will also need to go through all the elements in the array to validate. So essentially, this is going to be n log capacity range, and the capacity is going to depend on the length of wi, and in that case, it is going to be n log n essentially. So that is going to be the runtime complexity if you're trying to break it down, and the space complexity is going to be plain order of one because no matter how long this is, we're not going to store any values. So that is going to be a simple solution. With this is the runtime complexity, and this runtime and the space complexity. Now let's solve the problem and see if we can actually pass all the test cases. So in a binary search, we are going to select mean value as a left, and it's going to be the other side of the search range is going to be starting with 0, but so all the weights, so we are looking for the left side. So if W is greater than L, so our left is going to be the W value, and our right side is obviously going to be the summation of all the weights as we discussed. So now if we know the search range, at this point we can run a binary search uh, in, in logarithmic time. And in between we have to define the capacity, we could call it cap, and using bitwise operation, we can find the midpoint between L and R, and this is going to be the uh, the midpoint, and it is a floor division. So if there are only two values, L and R, in that case, it is going to uh, select the left value. And if you have the capacity, we need to check if we can ship within the days, right? So we can actually call it just can ship, or we can just call a function called feasible. And what do we have? We will need the weights. Sorry. Uh, Weights and capacity and days values. And if this is feasible, then we know that, okay, in the binary search, the current capacity that we're assuming is possible. So because we're trying to minimize, we can now take the current value as one of the valid answers and look for towards the left side of our search area. So that also means we are going to just shrink the search area for the right search space. And if it is not visible, then we know that we have to just increase our search space to the right, and we should exclude the current point. And in that case, uh, this is not a midpoint, this is actually capacity, and we're just going to take the next value. And once after repeatedly getting rid of almost half of the search space, we will end up at a point where L will be equal to R, and at that point we know that that is the only valid capacity at which we can ship all the weights within the given days, and that is going to be the answer. And at this point, you'll probably wondering, we we haven't defined this function yet, so let's actually define it now. Flesh it out and capacity, and we also need the days. And for this function, we need to count the number of days. So at the very beginning, we at least need 1 day to ship, right? And this is something you'll already see on this condition given on the left. And we also need to remember we initial load. And for each weight value, we are going to increase the load. And if our load is greater than the given capacity, we need to do a few things. At this point, we know that we need another day for another shipment. Uh, so we just increase the count, and we also set the load to be the current load because all the previous loads will need to be shipped in previous uh, shipment. And now at this point, if our count of days is greater than the given values, what do we do? We just now have to return false, right? And if that is not the case, we have searched through all the weights and we know that okay, we didn't actually uh, return false earlier, then we can just return true. Or you can also say count is less or equal to days. But we don't need to do that operation because we know this is going to be true anyway. Because by the time for the last value, it didn't go through this line and return false, then we still have the number of days within the given value. And at this point, if you run through the examples on the left and the right, you can see it will just work nicely. Uh, for the first example, 1 through 10 and days equals 5, we can do that, but that example is going to be very big. And instead, let's take the second example, 3, 2, 2, 4, 1, 4. And for this example, the sum of all the values is 3 plus 2 plus 2 plus 4, and 3, 5, 6, 7, 8, 12, 13, and 4, 17. So between one, that is the maximum value of capacity, and the smallest value is 4. So between 4 and 17, this is going to, the summation is 21. So the midpoint capacity will be around 10. And with that, you will see that you can definitely ship everything within 10 days because for the first 3, 4, 5, 6, 7, so first 3 is shippable in the first day, and the last 3, 4, 1, 4 are shippable in another day. Now within 4 and 10, you will have a midpoint of 7, and within 7 days, uh, you will still be able to ship within 3 days because the first 3, 4, 5, 6, 7 can be shipped in 1 day, and the second and 4 and 1 can be shipped in another day, and the last 4 can be shipped in another day. So you can still do that. Now between 4 and 7, you will end up at a midpoint at 5, and in 5 you will need to ship the first to 3 and 2 in one day, and then number 2 in another day because you cannot combine that with 4, and then 4 and 1 will be shipped in one day, a third day, and by the time it reaches 4, you already have exhausted number of days, so you need 4 days. So now you know that 5 is not going to work. Now you have 6 and 7, right? Because you have to exclude 5 and you have 6 and 7. And if you do that, you will see it will select 6 as the midpoint, because in our example, this line that selects the midpoint is going to be floor division. So with 6, you will see that 3, 4, 5, these two numbers are shippable in one day, and then 2 and 4 can be shippable in another day, and the last 2, 1 and 4 can be shipped in another day. So that is shippable in 3 days. Now with that, you will have 6 and the right side will be shrunk because we don't need 7. Now you can actually focus on 6 only. And at this point, it's going to actually stop and it will return 6. So with that explanation for the one example, let's run this code for the test cases. So you see, the first test case, second test case, and third cases, all of them actually passed. And I just verbally went through this second test case. And if you submit the solution, you will see we're going to pass. Yeah, beautifully. And thank you for watching.